Think about the entire universe, every star, every galaxy, every atom in your body, and imagine it all squeezed into a space smaller than the head of a pin. It wasn't just small, it was infinitely hot and infinitely dense. Then, in the blink of an eye, it exploded into existence. This is the Big Bang, the moment time itself began about 13.8 billion years ago.
Wait, hold on. You're telling me that everything we see outside a telescope today literally came from a microscopic dot? That sounds less like science and more like a magic trick. How do we even start to prove something that happened billions of years before humans existed?
It does sound like science fiction, but it's the bedrock of modern cosmology. Today we're diving into how a Belgian priest and a guy with a massive telescope changed how we see the heavens forever. We're tracing the history of the universe from a single point to the vast expanse we're drifting through right now. Most people think the Big Bang was a sudden explosion in the middle of empty space, but that's the first big misconception. There was no outside. Space and time were created by the expansion itself. Before the 1920s, most scientists, including Albert Einstein, believed the universe was static, unmoving, and eternal.
So they thought it had just always been there? No beginning, no end, just a big cosmic wallpaper that never changed? That seems much more comfortable than a volatile explosion.
Exactly. But in 1927, Georges Lemaitre, a physicist who also happened to be a Catholic priest, proposed something radical. He used Einstein's own equations to suggest the universe was expanding. He called it the hypothesis of the primeval atom. He figured if things are moving apart now, if you hit rewind, they must have all started at a single point.
I bet that went over well. A priest telling the scientific community that the universe had a day one, like some sort of cosmic genesis. It sounds a bit biased, Alex.
Einstein actually told Lemaitre his physics were abominable. But then Edwin Hubble entered the chat. In 1929, Hubble used the world's most powerful telescope to look at distant galaxies. He noticed something strange. The light from these galaxies was redshifted. In simple terms, they were moving away from us. And the farther away they were, the faster they were at fleeing.
So Hubble actually saw the expansion in real time. That changes the argument from a philosophical theory to an observational fact. If the universe is growing like a balloon being blown up, it definitely had to start small.
Once we accepted the expansion, the timeline started to fall into place. We call the very first moment the Planck epoch. For the first 10 to the power of minus 43 seconds, human physics basically breaks down. We don't even know if gravity at that point worked the way it does now. It was a period of pure, unified energy.
Okay, so total chaos, but how did we get from that white-hot mess to things like hydrogen or, planets? Dirt doesn't just pop out of an explosion.
It took some cooling down. About a microsecond after the start, the universe expanded and cooled enough for quarks to clump together into protons and neutrons. This is the Hadron epoch. A few minutes later, the temperature dropped to about 1 billion degrees, positively chilly compared to the start, and the first atomic nuclei began to form in a process called Big Bang nucleosynthesis.
1 billion degrees is chilly? Perspective is everything, I guess. So now we have the building blocks, but what about the light? When did the lights actually turn on?
Not for a long time. For the first 380,000 years, the universe was a hot, foggy soup of plasma. Light couldn't travel anywhere because it kept bumping into free-roaming electrons. It was essentially a cosmic blackout. Then the universe cooled enough for electrons to join with nuclei to form neutral atoms. This cleared the fog and allowed light to travel freely through space for the first time.
That sounds like a let there be light moment for real. Do we have any proof of that first light, or are we just taking the math's word for it?
We actually have a picture of it. Well, a map. In the 1960s, 2 guys at Bell Labs found this weird background hiss on their radio antenna. They thought it was pigeon droppings on the equipment, but after cleaning it, the noise remained. It turned out to be the cosmic microwave background radiation. It's the literal afterglow of the Big Bang, stretched out over billions of years into microwave frequencies. It's everywhere in the sky, in every direction.
So we're basically swimming in the leftovers of the beginning of time. That's wild. But if everything is flying apart, what stops it? Is the universe just going to keep growing forever until everything is too far apart to see?
That's the big question. For a while, scientists thought gravity might eventually pull everything back together in a big crunch. But in 1998, we discovered that the expansion isn't slowing down, it's accelerating. Something we call dark energy is pushing everything apart faster and faster. We're heading toward a big freeze, where galaxies will eventually be so far apart that the night sky will look completely empty from Earth.
This is heavy stuff, Alex. It makes us seem pretty insignificant. Why does the average person need to care about what happened 13 billion years ago? Why does this theory matter more than any other story about how we got here?
It matters because it's the ultimate origin story backed by hard data. The Big Bang Theory correctly predicted the abundance of light elements like hydrogen and helium in the universe long before we could measure them accurately. It explains why the sky is dark at night and why we see galaxies moving away from us. It tells us that we live in a universe with a history, one that evolved from simplicity to the incredible complexity of stars, planets, and life.
It also forces us to face the fact that the universe isn't static. It's a dynamic, changing thing with a beginning and presumably an end. It turns the entire cosmos into a single unfolding event that we just happen to be part of.
Exactly. Without the Big Bang, we don't have the heavy elements created in the first stars, which means we don't have the carbon in our DNA or the iron in our blood. We are quite literally made of the debris of that initial expansion. Understanding the Big Bang is the only way to understand our own biological history.
It's the ultimate started from the bottom story. All right, hit me with it. What's the one thing to remember about the Big Bang?
Remember that the Big Bang wasn't an explosion of matter into an empty room, but the rapid expansion of space itself, carrying all the energy of the universe with it. That's Wikipodia. Every story on demand. Search your next topic at wikipodia.ai.